Number 39, the emergency cell phone charger requires you to turn a small crank in order to create the energy needed to recharge the phone's battery. If you turn the crank 120 times per minute, the total number R of revolutions that you can turn the crank is given by. So revolutions equals 120 times T, where T is the number of minutes. We just asked you to do part B here. Identify the domain and range if you stop turning the crank after 4 minutes. Well, the least amount of time you can turn the crank is 0 minutes if you don't turn it at all. And they're saying they want us to stop the crank after 4 minutes. So really, as far as T goes, the number of minutes, T could be anywhere between 0 and 4. So we say 0, less than or equal to T, less than or equal to 4. The range of the graph, if you think about if I don't turn the crank at all, if I turn it for 0 minutes, 120 times 0 would be 0 revolutions. If I crank for all 4 minutes, 120 times 4, that's going to be 480 revolutions. So R, the number of revolutions, is going to be somewhere between 0 and 480. How does this affect the appearance of the graph? If we don't have a restriction, the number of revolutions would just keep going up and up and up as more minutes go by. Obviously, it would have to stop at 0 because you can't have negative revolutions. I suppose the graph would be more like this, because if I turn it for 0 minutes, it's going to have 0 revolutions. It would just keep going up and up and up as the minutes go by. But if I stop it after 4 minutes, it's going to turn that ray into a line segment as far as what the graph actually appears like.